parallel circuit rules. So what we're going to start here is we're going to draw a parallel circuit up here. So what I'll do is I'll put a voltage source here, and I'm going to put 3 resistors in parallel like this. And then I'm going to go ahead and label them, knowing that this is R1, R2, and R3. Each one of these resistors is going to have a current running through it, I1, I2, I3. It's going to have a voltage drop, I1, V1, V2, V3, and it's going to dissipate power, P1, P2, P3. Okay, so these are the rules, and now we want to draw the mathematical equivalent to this. So the voltage drop across any circuit branch is the same. So in a parallel circuit, the voltage stays the same. So if this was 120 volts over here, we know that across the top and the bottom here, we have a drop of 120 volts. So V1, V2, and V3, it's going to be the same. So the total voltage, VT, over here of 120 volts, is equal to V1, which is equal to V2, which is equal to V3, which is equal to Vn, depending on how many loads. So all these loads get the same voltage, okay? The current total is the sum of the current through each of the branches. So this voltage source will generate a current, and that current will flow here, but it will get divided. Some of it will go this way, and some will go this way, and some will go this way. And so the mathematical formula here is that I total, which is we generated my I total right here. Here's my I total. It's going to be equal to I1 plus I2 plus I3 plus as many loads as you would have IN. Okay, so these currents, this plus this plus this, would add up to be equal to that, because the current, none of it can be lost. It can be divided up, then it's got to then come back together. Okay, and it would equal the total. The total active power is the sum of the resistor's active power. So once again, power total. This is going to dissipate heat, this dissipate heat, and this dissipate heat. It's going to be P1 plus P2 plus P3 plus all the way up to the number of loads that you have. So this power plus this power plus this power. The total resistance is equal to the reciprocal. So now here, if we wanted to get the total resistance here to simplify this, we would have to say 1 over RT, the reciprocal of the total resistance, is equal to 1 over R1 plus 1 over R2 plus 1 over R3 plus 1 over all the way up to Rn, okay, depending on number of loads. So the reciprocal of this plus the reciprocal of this plus the reciprocal of this is equal to the reciprocal of the total, so you would have to do x minus 1 and flip the total here. So those are the mathematical equivalents to the parallel circuit rules.